Have you ever gazed at the night sky and wondered if our universe is all there is? What if everything we know is just one bubble in a vast cosmic ocean? This isn't just science fiction, it's a real question at the edge of modern physics. The multiverse theory suggests our universe could be one of countless others, each with its own laws and possibilities. Some might be similar to ours, others could be unimaginably different. Imagine our universe as a single grain of sand on an endless beach. What if there are infinite grains, each a universe with its own story? The multiverse challenges our understanding of reality and invites us to explore the ultimate frontier. So let's set sail on this cosmic journey together. So what is the multiverse? It's a question that's fascinated scientists, philosophers, and science fiction fans alike for decades. The idea might sound wild, but it's rooted in some of the most cutting-edge theories in physics. Simply put, the multiverse is the concept that our universe, everything we can see, touch, and measure, is just one among countless others, each with its own unique properties and laws of physics. Imagine a giant apartment building stretching endlessly in every direction. Our universe is just one apartment, one room in this cosmic complex. The other rooms are sealed off, invisible to us, but they might be just as real as our own. The term multiverse actually covers several different scientific ideas. Some come from quantum mechanics, where particles can exist in multiple states at once, while others arise from cosmic inflation, the rapid expansion that shaped our universe right after the Big Bang. These theories weren't dreamed up just for science fiction. They're natural consequences of the equations that physicists use to describe reality. When scientists follow the math, the possibility of other universes often pops up. In fact, the mathematics often suggests not just one universe, but a vast collection of them, each completely separate from ours with no way to travel or communicate between them. These other universes aren't just faraway galaxies, they're entirely different realities, unreachable by any telescope or spacecraft, existing beyond the limits of our observable universe. So why do scientists take the multiverse seriously? Because the very same theories that predict a multiverse also help explain the things we actually observe, like the uniformity of the cosmic microwave background or the distribution of galaxies. For example, the theory of cosmic inflation not only explains why our universe looks the way it does, but also predicts that new universes are constantly being born, like bubbles in a boiling pot. Ignoring the multiverse would mean ignoring where the math and evidence are pointing us. It's not just a wild guess, it's a logical step in our quest to understand everything. The multiverse isn't just idle speculation, it's a profound consequence of our best scientific theories, challenging us to rethink our place in the cosmos and what reality might truly be. The multiverse isn't just a single idea or a simple concept to grasp. Instead, it's a vast family of theories, each one offering a unique perspective on the nature of reality and what might lie beyond our own universe. Take the many worlds interpretation of quantum mechanics, for example. It suggests that every quantum event, no matter how small, splits reality, creating a new, parallel universe for every possible outcome. In this view, there could be countless versions of you, living out every possibility. The bubble universe model, born from inflation theory, imagines our universe as just one bubble in a vast cosmic foam. New universes are constantly forming, each with its own laws of physics and unique histories. String theory introduces the brain world scenario. Here, our universe is a three-dimensional brain, floating in a higher dimensional space, possibly alongside countless other brains, each one a separate universe with its own reality. Sometimes these brains might even collide, unleashing unimaginable energy and triggering events as dramatic as the Big Bang itself, giving birth to entirely new universes. Then there's the mathematical universe hypothesis. It proposes that if mathematics can describe a possible reality, then that reality must exist somewhere as its own universe, no matter how strange or abstract it may seem to us. This means that every consistent mathematical structure, no matter how bizarre, could be a real universe existing in a vast mathematical landscape. The multiverse, if it exists, could be unimaginably vast, filled with universes stranger and more diverse than anything we can currently imagine or even comprehend. Each theory paints a different picture of what other universes might mean, challenging our understanding of existence itself. Together, these ideas form a cosmic catalog of possibilities, a grand collection of realities, each waiting to be explored by science and imagination alike. Let's dive into the strangest multiverse theory, the quantum many-worlds interpretation. In quantum mechanics, particles exist in a cloud of possibilities until measured. Hugh Everett proposed that instead of choosing one outcome, the universe splits. Every possibility happens, each in its own parallel universe. Every coin flip, every decision, creates a new branch of reality. There are countless versions of you, each living out different choices. These parallel worlds are completely separate. We can't communicate or travel between them. The mathematics of quantum theory supports this branching without extra assumptions. It's an elegant solution to quantum puzzles, but it means reality is unimaginably vast. We are each just one of infinite versions, all equally real but forever out of reach. The price of this elegance is a universe filled with ghostly copies of ourselves. Now let's zoom out to the cosmic scale and explore some of the most mind-bending ideas in modern physics. The bubble and brain world multiverses. These theories challenge our understanding of reality and suggest that our universe might be just one of many, floating in a vast cosmic sea. The bubble universe theory proposes that our Big Bang was not unique. Instead, it was just one event in an endless process. Our universe is a single bubble in an ever-expanding, inflating ocean of space with new bubbles or universes forming all the time. Each bubble is like a separate universe, isolated from the others by the vastness of the cosmic sea. Each of these bubbles could have its own unique set of physical laws and constants. Some might be too chaotic or inhospitable for life, while others could be stable and nurturing, just like ours. The diversity among these universes could be unimaginable, with some so strange we might not even recognize them as universes at all. Our universe happens to have the Goldilocks conditions. Everything is just right for complexity, chemistry, and life to emerge. This delicate balance allows stars, planets, and living beings to exist. The brain world idea, inspired by string theory, takes things even further. It suggests our universe is like a three-dimensional membrane or brain, floating in a higher dimensional space. There could be countless other brains, each one a separate universe, stacked or drifting nearby in dimensions we can't perceive. Imagine we're like ants living on a sheet of paper. We can move around on our surface, but we're completely unaware of other sheets, other brains, floating just out of sight, perhaps only a tiny distance away in another dimension. These other universes could be just a millimeter away in a direction we can't access, separated by invisible barriers. We can't see, touch, or interact with them, at least not directly. However, some theories suggest that gravity might be able to leak between brains, offering a tantalizing possibility. If we could detect these subtle gravitational effects, we might find evidence of other universes lurking just beyond our own. These ideas are highly speculative, but they push the boundaries of what we know and inspire scientists to search for clues in the cosmic background, in gravitational waves, and in the deepest mysteries of physics. So our universe may have cosmic neighbors closer than we ever imagined, just out of reach, waiting to be discovered as we continue to explore the frontiers of science. The idea of multiple worlds isn't new, it dates back to ancient Greece. Philosophers like Democritus imagined infinite atoms forming infinite worlds, some like ours, some wildly different. For centuries this was philosophy, not science. In the 19th century, William James used multiverse to describe the complexity of human experience, not cosmology. The scientific revolution came in the 20th century, Hugh Everett's many worlds interpretation in 1957, and later, the theory of cosmic inflation in the 1980s. Everett's idea was ignored at first, but gained traction as quantum puzzles persisted. Inflation theory, developed by Alan Guth and Andre Linde, led to the bubble universe scenario. Suddenly both quantum mechanics and cosmology pointed toward other universes. What began as ancient philosophy is now a serious, if controversial, scientific hypothesis. The multiverse sounds fantastic, but is it science? Science needs evidence. Proving other universes exist is a huge challenge, but scientists have ideas. One is to look for bruises in our universe. If another bubble universe collided with ours, it might leave a mark in the cosmic microwave background. Scientists have searched for these patterns, but so far nothing conclusive. In quantum mechanics, some think interference patterns hint at parallel worlds, but this is more interpretation than proof. Experiments to distinguish between quantum theories are ongoing, but results are elusive. The anthropic principle offers another clue. Our universe's laws seem fine-tuned for life. If there are countless universes, it's not luck. We're in one of the few where life is possible. The multiverse could explain why our universe is just right for us. For now, the evidence is indirect, but the search continues. The multiverse is controversial, facing serious scientific and philosophical challenges. The biggest issue is testability. If other universes are forever out of reach, can the theory ever be proven or disproven? Critics argue that untestable ideas belong to philosophy, not science, and risk undermining the scientific method. Another problem is infinity. Many models predict infinite universes, making meaningful predictions difficult. In an infinite multiverse, every possibility happens somewhere, making probability calculations nearly impossible. This is called the measure problem. How do we calculate the odds of finding ourselves in a universe like ours? Without predictive power, the multiverse theory loses scientific value. Scientists are working to address these issues, but for now, the multiverse remains on the fringes of science. It's a fascinating idea, but not yet universally accepted. The debate continues, pushing us to refine what we mean by science. After exploring branching realities and hidden dimensions, is the multiverse science or science fiction? For now, it's both. The multiverse is born from our best theories but remains on the edge of what we can test. We can't visit other universes, physics forbids it. But the idea matters. It's the ultimate step in realizing we're not special, just one universe among many. The multiverse humbles us, expanding our perspective and curiosity. It encourages us to keep asking big questions and exploring the unknown. Whether or not we find proof, the search itself drives science forward. It deepens our appreciation for our own universe. And it keeps us looking up, wondering what else is out there.